Jai Hind everyone. The topic which we are going to discuss today is process model, which comes under the category of software engineering. So basically, what is process model? First, we need to understand this concept. So in the software development projects, they are very large generally when you are developing a large model. For example, if you are developing a software for a university, then no doubt it is having multiple stakeholders, and according to such a large amount of stakeholders, the project which you will develop, it is going to be very large. So you need to control it, the planning, the timely delivery of the project, the cost of the project, all these factors need to be controlled, and the progress need to be monitored. People and resources need to be allocated at the right point in the time so that you can efficiently utilize the resources and people. So to solve the actual problems in an industry setting, a software engineer or a team of engineers must incorporate a development strategy, a development model that encompasses the process, methods and tools layers. This strategy is generally termed as process model. So a process model for software engineering is chosen based on the nature of the project and application. And once we are saying the nature of the project, then what are the factors we are incorporating in this particular point? Number one is your risk perception. Then comes understanding the app and application skill of the software engineer, that is whoever the development team allocated to you. Then comes the domain knowledge of the software developer. The methods and tools to be used, they are also play a major role when you decide what kind of process model you will use for developing a software product. Then the controls and deliverables that are required, that is what are intermediary products you require when you developing the software project. So if we see a problem solving a process in general, then it implies first we need to define what is the problem, that is we require this particular path, what is problem definition. After defining the problem, you go to the development part, and here you go with the solution integration and all these things. Then comes the status quo, that is you will check whether that the solution which you desired, the solution for this problem has been implemented correctly or not. If not, then again you redefine this, you refine this problem. So this is a simple process, but for a large project, such kind of process cannot be implemented. So we need various models with the help of which we are going to develop the software project, and this process model is also termed as software development life cycle, because here in each and every model we are having different phases, and and if you adopt a certain model, then this implies you need to develop a project according to its phases only. So we are having SDLC for all these models, we are having waterfall model, incremental model, then we are having rapid application development model, we are having evolutionary rapid prototype model, and then we are having the spiral model. The two models which we are going to discuss is your incremental model and the spiral model in this lecture. So what is incremental process model? Initial software requirements, they need to be well defined, that is whatever the user wants from your project, from your software, that need to be defined in the very beginning. So compelling the need to provide a limited set of software functionality to users quickly, and then refine and expand on that functionality in later software releases. That is, first we will develop gather some user requirements, we will develop you could say certain functionality, and on the basis of this, and once you have developed these functionalities, implemented these functionalities, then you later on you will add other functionalities. So we are saying that we are developing a model in an increment fashion. So the incremental development, it is a process of constructing a partial implementation of a total system and slowly adding the functionality to it. This model combines elements of the linear sequential model with the iterative philosophy of prototyping. That is for developing a first iteration. During the first iteration cycle, you need to follow certain steps, and after following that certain steps, you will get a you could say a prototype or a version 1. After that, you will again add some new functionality to this already existing system. Again, you will follow those steps in the same orderly manner, and after that, you will get another iterative cycle. So this is your incremental model. So incremental model, it describes the process of prioritizing the requirements of the system and then implementing them in groups. So what it says, you are having a set of requirements, you will make a group of those requirements, and after, let's suppose we are having 3 groups of requirements, R1, R2 and R3. After that, we will prioritize them, and according to their priority, we will start implementing them. That is, for suppose in the iterative cycle 1, we will work on R1. Then in other iterative cycle, we will work on R2 and then R3. So once all these groups of functionalities has been implemented, the final output is going to be your software project. Each subsequent release of the system adds function to the previous release until all designed functionality has been implemented. So here, the early phases of life cycle, that is planning, analysis and design, they are considered the entire system to be developed. During these phases, the increments and the functions within them are defined for the development of that particular component. Each increment then proceed through the remaining phases of the life cycle: code, test and delivery. A set of functions that are the core or having the highest priority requirements critical to the success of the project, or that will reduce the risk, is constructed, tested and implemented first. That is, which are having the highest priority or which are critical to the success of your project, you are going to implement them first. For example, word processing software developed using the incremental paradigm might deliver the word processing software editing and document production functions in the first increment, what you are including only addition and the document production part. Then for more sophisticated editing and document production capabilities in the second increment may be grammar check, spell check, then spelling and grammar checking in the third increment, advanced page layout capabilities, your printout capabilities or other indentation capabilities, they can be added in the fourth increment and so on. So if we talk about the incremental model, in this case, first we will go with the analysis and the design phase, in which we will follow a full-fledged system engineering approach. After that, we will go with the code, test, and this is my increment 1, and here I am having the delivery of my first increment or first iteration. Then comes the increment 2. Here again I will repeat the process, but here this is quite a refiner part, that what other things can be done, and then coding, testing, delivery of this product and so on. So here we are having increment 3, increment 4 and so on. So delivery of the fourth increment may be considered as the final delivery of the project. What are the strengths of this approach? Funds for a total product development need not be expended up front, that is during the initial time, because a major function or high risk function is developed and delivered first. An operational product is delivered with each increment, that is at the end of each increment, whatever you are getting, you can work on this. It is a working project or a working prototype at the end you are getting. Lessons learned at the end of each incremental delivery can result in positive revision for the next. That is, whatever difficulties you have faced in the previous iteration, it will with the help of those that difficulty, they will provide a positive revision for the next phase. The customer has an opportunity to respond to each build. That is, after each increment, the customer is also using the that particular increment, so he can give the feedback. The divide and conquer rule allows the problem to be broken down into manageable pieces. So limited staff can be used with the same team working sequentially to deliver each increment. Risk is spread across several smaller increments, which is a very important thing here, instead of concentrating in one large development. But it is having its limitations also. The definition of a complete, fully functional system must be done early. And on the basis of this only you are able to decide that which requirement will come under group R1, which come under R2 and which come under R3. Well-defined interfaces are required because some modules will be completed long before others. Formal reviews and audits are more difficult to implement on increments than on a complete system, because here what you are reviewing just particular increment. But at the end, may be possible when you got a complete system, its quality is not up to the mark. The customer must realize that the total cost will not be lowered. It requires good planning and designing. Management must take care to distribute the work, and the technical staff must watch the dependencies among themselves. So now the question comes, where we are going to use this model, which particular software projects they are more suitable for this model. So when most of the requirements are understood upfront but re-expected to evolve over time, then in that case we can go with this. When there is a short market window and a need to get basic functionality to the market quickly, then this is the best approach. On projects that have lengthy development schedules, usually over 1 year, again incremental model is suitable for such kind of projects. On low to medium risk programs, we can go with this model. On a project with new technology, allowing the user to adjust to the system in smaller incremental steps rather than leaping to a major new product. And when it is too risky to develop the whole system at once, it is best to go developing in increments. Next important model is our spiral model. It is basically proposed by Barry Boham in 1988. The process is represented here in this particular model as a spiral rather than as a sequence of activities, which we have seen in the increment model. And here the sequence of activities, we are having a feedback, that is with backtracking is possible in this case. Each loop in a spiral represents a phase in the process. Thus, the innermost loop might be concerned with the system feasibility. The next loop is concerned with system requirement definition. The next loop with the system design, and so on. So, here we are having such kind of thing in this case. So, here this is my inner loop. So, I could say this all the activities in this loop corresponds to system functionality. In the next loop, it corresponds to my system requirement definitions, and so on. So this is our spiral model. So here if you look, this is my quadrants, this is my determine objectives, alternatives and constraint quadrant. In this quadrant, we are evaluating the alternatives, identifying and resolving the risk. Basically, spiral model. In this model, we are including the risk factor also. Here, we are having develop, verify, next level product we are having, and in this phase, in this quadrant, we are having planning for the next phases. Now, in each quadrant, we are doing certain kind of activities. For example, here what we are doing, we are reviewing the things. Here, we are doing the risk analysis, as well as we are also developing the prototypes until we get the operational prototype. And while identifying the risk, we are also analyzing the risk. In this quadrant, we are simulating the models, we are having benchmarks, then we are having software requirements, product designing, detailed designing, coding and testing part. All these things, it come under the category in this quadrant. In the planning next phase, what we are planning for the next phases. So if I talk about this particular phase, we are having requirements plan, life cycle plan. Here we are having development plans, then we are having integration and test plan. On the basis of this, what we are doing this testing. So, spiral model, it is cyclic in nature. Each cycle of a spiral consists of 4 stages and each stage is represented by one quadrant. The radius of the spiral represents the cost accumulated so far in the process and the angular dimension represents the progress in the process. The focus is the identification of problems and the classification of these into different level of risk. So, the main aim is eliminate high risk problems before they threaten. So, this is the main objective of the spiral model. Each phase is completed with a review of all products developed up to that point and includes the planning for the next cycle. These plans may include partition of the product in smaller portions for development that are implemented by individual groups or persons. So, it can be viewed as meta model because it becomes equivalent to another life cycle model in appropriate situations. So, here what we are having? We are having planning in this quadrant and here we are having risk analysis. Here we had adopted the engineering approach and here we are having the review process, that is your quality evaluation process in this quadrant. So, this is a simplified view of the spiral model. Here only in this quadrant we are making the decision whether we will go with the project or not, or whether we will go with the next spiral or next phase or not. So, the quadrant 1, that is here. What we are having? We are having planning, so initial requirement gathering, project planning and the project planning based on the customer commitment, all things need to be done in this phase. So, objectives such as performance, functionality, ability to accommodate the change, we need to find out. For instance, we are moving towards the next phase, so we need to identify whether we are able to accommodate the changes or not. What are the hardware software interfaces required, critical success factors of that particular phase, all things need to be determined in this particular quadrant. Alternative means of implementing this portion of the product are determined. Constraints imposed on the application of the alternatives, that is what is a cost, schedule, interface, environmental limitations and so on. And the risk associated with lack of experience, new technology, tight schedules, poor process and so on are documented. In the quadrant 2, we can evaluate the alternatives and identify and resolve the risk. So, alternative means relative to objectives and constraints which we have evaluated in the first quadrant. Then the identification and the resolution of risk, that is risk we have already identified in the quadrant 1. Here the risk management, cost effective strategy for resolving sources, evaluation of remaining risk where money could be lost by continuing the system, development, etc. Such kind of activity happen in this quadrant 2. In quadrant 3, we are developing the next level product. So, typical activities which are related to the development of a product, that is creation of a design model, review of design model of that particular software, development code, then the inspection, testing and packaging. All these things they are being, that is why we are saying it is pertaining to my engineering approach. The first build is the customer's first look at the system. With each subsequent build, that is in each spiral or in each phase, a better idea of customer requirement is developed. The degree of change from form on build to the next diminishes with each build and eventually resulting in an operational system. In the quadrant 4, what we are doing? We are planning for the next phase. So, typical activities which are involved in this phase are, in this quadrant are development of the project plan, development of the configuration management plan, development of the test plan, development of the installation plan. So, what are the advantages of this model, strengths of this model? The spiral model allows the users to see the system early, that is after first phase. The user can see what that particular system is going to do. Through the use of rapid prototyping in the development life cycle, it provides early indications of insurmountable risk with without much cost. It allows the users to be closely tied to all planning, risk analysis, development and evaluation activities. It splits a potentially large development effort into small chunks in which critical high-risk functions are implemented first, thus allow the continuation of the project to be optional. So these are the advantages. The spiral model, other advantages are it provides early and frequent feedback from users to developers, ensuring a correct product with high quality. Management control of quality, correctness, cost, schedule and staffing is improved through review at the conclusion of each iteration. It provides productivity improvement through reuse capabilities. All money needed for the project need not be allocated first, and it could be distributed among the your phases. Cumulative cost may be assessed frequently, and a decrease in risk is associated with the cost. But what are the disadvantages or limitations? If the project is low risk or small, this model can be expensive one. Then you need to go with some other model. The time is spent evaluating the risk after each spiral is costly, because risk evaluation is being done in each phase. The model is complex and developers, managers and customers may find it too complicated to use. So considerable risk assessment expertise is required here. The spiral may continue indefinitely, generated by each of the customers' response to the build, initiating a new cycle, and the closure may be difficult to achieve in this case. It can be hard to define objective, verifiable milestones that indicate readiness to proceed through the next iteration. So where we can use this model for projects that represent a medium to high risk, where it is unwise to commit to a long-term project due to potential changes in economic priorities, and when these uncertainties may limit the available time frame. When it is important to focus on stable or known parts while gathering knowledge about changing parts. When new technologies are being employed, such as first-time object-oriented approaches and so on. So here you can go with the spiral model, this process model. These are the readings which is being suggested if you want to learn more about spiral model or your incremental model. Thank you and Jai Hind.